Very good day, everyone. So this would be the outline of our learning today. Okay, gradient of a scalar function, divergence of a vector field, and curl of a vector field. Okay, so we all know that we are already going to chapter 5. Okay, chapter 5. So this chapter 5, we are going to learn about the vectors calculus. Okay, vector calculus. So in this chapter, we are going to go through a few subtopics. So beside the three, okay, that I mentioned over here, we are going to learn about the line integrals. Okay, we are going to learn about how to perform the line integrals of scalar and vector field. And we are going to learn also the surface integral of scalar field. And also lastly, the divergence theorems. And also the Stokes theorems. So the calculation in this chapter is to support the calculations of the subject electromagnetic fields and wave, because in that subject you are going to deal with many integration problems and also derivations of equations. Okay, so you need to understand all the concept of how to perform the line integral and also the surface integral. Okay, so without delaying, let's go to the first sections, okay, that we are going to go through today. That is a gradient of scalar functions. Okay, gradient of a scalar functions. Okay, so usually for the gradient of the scalar functions, we are going to represent it with this symbol. This is what we call it as a del. Okay, del multiply with the functions. Okay, I think everybody, you know what is scalar functions, right? Scalar functions is the functions that only has the magnitude. It doesn't have the directions. Direction means it is I, J, K directions. Okay, so for scalar functions, okay, it doesn't has any directions. And when you put it together with this symbol we call it as a del. Okay, the del operator. Okay, we put it together with the del operator, we call it as a gradient of a scalar functions. Okay, so here you need to know that the del, okay, can be represented by dx I plus dy j and plus dz. Okay, so when you put it together with the functions, okay, it means that, okay, you have to perform differentiations. Okay, now you put it together with the f, right? So meaning that you are going to have, okay, you are going to have differentiation with respect to f, okay, with respect to x, sorry, differentiation with respect to the y, and differentiation with respect to the z. Okay, so you are going to put them into the ijk component. So this is how you perform the gradients of functions. Okay, let's look at one example. Okay, so example 1. So find the gradient of the following scalar function. If I give you that you have a functions, okay, so this is a xy functions. It has x and y component, and you are going to find the gradients of the functions. Okay, so what you have to do is you apply the formula over here. So how to apply? Okay, so this is equals to fi plus k. Okay, so for this itself, you have to differentiate the function with respect to the x. Okay, so when you differentiate it with respect to the x, you have 2 plus y. Okay, so these belong to your I component. And for the second term, you have to differentiate with respect to the y. Okay, so you will have a 0 plus x, right? So this is your j component. And for the differentiation with respect to the z, it will be equal to 0 because there is no z components. So as a result, okay, so the gradients of this function will be equals to 2 plus y I, okay, plus sj. Okay, so this one will be the gradient of your functions. Okay, it's very easy. Now let's look at the second example. Now this is example 1. We look at example 2. Okay, finding the gradient also. So we have functions x, y, z. So we have 2 exponent xy cos z. Okay, so you have to find what is the gradient of these functions. Okay, so we're going to apply the same formula. Okay, this one. Okay, so I'm going to use this symbol to represent it. Okay, it is the same meaning as the previous one, right? Okay, this one is equals to fx, right? This one is equals to fy, and this one is equal to fz. I'm just using different representations, yeah? Okay, so now I'm going to differentiate the function with respect to the x. So I have 2 cos z, they are constants. Okay, so I write them out, exponent xy again. And I differentiate with respect to the x, I get y. Okay, so this is my item. And then now I differentiate with respect to the y. So I have 2 cos z exponent xy. Differentiate with respect to the y. So I have x. And lastly, differentiate with respect to the z. So I have 2 exponent xy. Cos will become negative sine z. Okay, negative sine z. Okay, so the negative, I'm going to place it here. Okay, this one I missed. Okay, negative, and this one is k. Okay, so this one is the answer. You can just leave your answer like this, or if you want to rearrange it also, okay? So this is how we find the gradient of the function. I think it's very clear, right? Okay, so now we go to the second things that we have to learn today. Okay, that is the divergence of a vector field. Okay, divergence of a vector field. Divergence of a vector field, FIELD. Okay, so for the divergence of a vector field, we will always represent it with del dot f. Okay, del dot f. So what you can see over here, del, okay, so just now I already introduced you what is del, what is the formula. So this formula, you are going to dot product with a vector field. Okay, this is a vector field because you see that there is an arrow over here. Okay, so you can only find a divergence of a vector field instead of divergence of a scalar field. Okay, we only do for the vector field. So how do we do the divergence of vector field? So if you have to perform the divergence of vector field, okay, so you are going to, okay, let's say that, yeah, let me write down again. So the del, you already know that it is equals to del xi plus del yj and plus del zk. Okay, this is the del that we know. So for example, now you have a vector field and your vector field is represented by mi, okay, plus nj and plus pk. k. Okay, so when you have the dot product, okay, between terms, this means that you have to multiply component by component and then add them together. Okay, remember how to do it? Okay, so divergence of a vector field will be equals to del x multiply with the m and plus del over del y multiply with the n and plus del over del z multiply with the p. So what you can observe here is after you perform the dot product, okay, so the answer now is scalar quantity. Scalar quantity. Scalar quantity. It means that you see there is no more ijk component. It will be a value after you perform the divergence of a vector field. Okay, so let's look at one example how to perform the divergence of a vector field. So given that you have a vector f, okay, it is equals to 2x 3y. Okay, I think everybody is clear what's the meaning of this bracket. Okay, this means that it is the vectors. Okay, so when we have to find the divergence of the vector f, it will be equals to del over del x. Okay, so now the m will be these terms, the n will be these 3y, and there is no p, so the p is equals to 0. Okay, so we're going to differentiate 2x, okay, and plus it when we want to differentiate with respect to 3y. Okay, so just follow the equations. So it will be equals to 2 plus 3, which is equals to 5. Okay, it's very easy how we perform the divergence, okay, of a vector field. Let's look at one more example. Example 4. So let's say if we have f equals to y square I minus xj. So now we have to find the divergence, okay, of a vector field. So it will be equals to del x, okay. We perform the differentiations for this y term, item, okay, sorry, and plus differentiate with respect to y for the j term. Okay, so here we don't have the x, so it is 0, as well as this part, it is 0, so it will be equals to 0, right? Very simple, the concept. You just need to multiply term with term. Okay, so this is the part that you need to understand, just like how you do the dot product, right? So when you're doing the dot product, you will multiply term with term, okay, and add them all together in order to get the divergence of a vector field. Okay, so you're clear? Okay, we go to the next term. Okay, we go to the next term. That will be the curl. Oops. Okay, that will be the curl of a vector field. Okay, so again, it is dealing with the vector field. So for the curl, okay, we are going to replace the dot at the middle, okay, of them with cross. Okay, so when it is cross, okay, we call it as the curl of a vector field f. Okay, so how to perform this curl of a vector field? So I think everybody, you still remember, okay, so for the del, it is equals to this. Okay, so this is your del. Okay, now you have a functions. Okay, I'm going to using the m to represent the I component, n to represent the j component, and p to represent the k component. So when we have to perform the cross product, so do you remember how to do it for the cross product, okay, of a vector field? Okay, you will have this, right? I G, okay, you arrange them in matrix. So you have del x, del y, del z, and then you will have an m, n, and also p component. Okay, so just like how you do the cross product of two vectors, right? Cross product. So for the I component, right, I component, if you still remember what I told you before that, hide the first row and also the first columns. So just multiply it. Okay, so it will be del y multiplied with p minus del z multiplied with the n. Okay, and this belongs to the I component. Okay, and for the j component, okay, you have to hide the second columns, right? And here it will be negative. Okay, negative del x p minus del z m. Okay, so this belongs to j component. And then for the last, okay, for the last, you will have to hide the last column, right, to represent the k components. So this one will be plus del x n, okay, minus del y m, okay, to represent the k component. Okay, so this is how you solve the curl of a vector field, okay, by performing the cross product between two vectors, that is the curl and also the vector itself. Okay, so now let's look at one example. Okay, let's look at one example. So we have example 5. Okay, find the curl of these functions. So now if we have a f, so this is a functions. So it is y negative x. Okay, so y represent the I component, negative x represent the j component, and you have to find the curl of a vector field. Okay, so arrange the A matrix. Okay, so the del is this, right? Okay, so you put your y and negative x here. Okay, so let's calculate this. Oh, this is 0, so just fill up with 0. Okay, so for the I component, 0 minus, okay, for this one, you have to differentiate with respect to the z, but you don't have z, so it is equal to 0. This is your I component. Right. And then for the j component, okay, it will be 0 minus, okay, so this one you're going to deal with this, right? Okay, so you cannot differentiate with respect to x, you get nothing, so still 0. Okay, and lastly you have the z components where you hide the last columns, right? So del x, negative x, you get negative 1. Okay, minus, okay, minus del y, so you get 1, so it is k. Okay, so this is how you perform, right? Differentiate with respect to the y and differentiate with respect to the negative x, so you get this, right? So your answer will be equals to negative 2k. So this is the answer of your cross product. Okay, we go to the next one. It is example 6. Okay, so let's say if our f is equals to exponent x plus y, okay, comma, sine y, comma, and cos square z. Okay, so this is our functions, our vectors. Now I want to find the curl of a vector f. Okay, the curl of vector f. So just arrange them, okay, into the metric form again and do the cross product. Okay. So you have exponent x plus y, sine y, and cos square z. Okay. So let's do the first one, the I component. Okay. So this will give you 0 because no y component. Okay, and this one also give you 0 because there is no y component. Sorry, x, z component. This is your I. And then now we move on to the second term. Okay, the j term. So this one will be multiplied with this. Again, you get 0. And this one you multiply with this. Again, you cannot differentiate. You get 0. So it's 0. And last term. Okay, last term. We still get 0. Okay. So this is multiplied with this. You get 0. And minus this, okay, so this is not 0, so you get exponent x plus y. So differentiate with respect to the y, you get 1, okay. So this is your answer, okay. Negative exponent x plus y k, okay. So this is all about today. How to perform the calculations or to find the gradients, okay, to find the gradients. So this will be the symbol. You want to find the gradient of a scalar functions, and you want to find, if you want to find the divergence, okay, so there will be a dot product between the del and also the things involved is a vector. So for the curl, it will be this. Okay, so these three will represent different meaning. You should be able to differentiate it and able to apply the suitable and correct formulation in order to count them, okay, in order to calculate them. So gradient is you calculate using this formula, and for the divergence, you have to calculate using this formula, okay, and the answer is a scalar. And lastly, you have a curl of a vector field where you have to perform the cross product, okay? So the answer is a vector quantity, yeah, because see you have ijk components, right? Ijk, so all these, they are vector quantity, okay? Vector quantity. Okay, so this is all about today to calculate these three terms. So please try the exercise. Thank you, class.